Hello, in this lecture we'll answer on two questions. In the first question, we will find out the radius of this quarter circle, and in the second question, we will find out the size of this angle theta, that is inside triangle ABC. So we'll start with the first question. In the drawing, we have a quarter circle. Line segment VC equals to 9 centimeter. Line segment CD equals to 16 centimeter. And line segment DL equals to 12 centimeter. And we also know that this angle ABC, angle OBC equals to 90 degrees, and this angle BCD equals also to 90 degrees, and this angle CDL, it is also equals to 90 degrees, and our mission is to find out the radius of this quarter circle. So we know that because of the fact that this is a quarter circle, then this point O, is the center of the quarter circle. So here you can write down that point O is the center of the quarter circle. And this angle AOF is equal to 90 degrees. It is true in any quarter circle. And the first thing that we know, that because of the fact that this is a quarter circle, then side AO is the radius of the quarter circle. Here, this is the radius of the quarter circle. So we define the radius of the quarter circle as capital R. And side OF, right segment OF, it is also the radius of the quarter circle, so we'll define it. So it is equal to capital R. So I'll write it down that capital R is equal to the radius of the quarter circle, according to our definition. Is the radius that we are looking for, actually, the radius of the quarter circle. Our mission is to find out the value of capital R. So capital R equals to the radius of the quarter circle. Okay. So we will extend the straight line CD by a straight line, and here we will extend the straight line CD by a straight line. So we have here, we define the touching point of the extended straight line CD with the radius OF as point M. Actually, we extended the straight line CD by a straight line, therefore when you extend a straight line by a straight line, then the result must be also a straight line. So CM, it is also one straight line. And by extending the straight line CD, we actually created here quadrilateral BCOM. So we know that in quadrilateral BCOM, we have 1, 2, 3 right angles. So we write it down. In quadrilateral BCOM, we have 1, 2, 3 right angles. And the sum of three right angles is 90 times 3 is 270 degrees, plus the size of this angle, it is actually angle DMO. That's angle DMO. In total, the sum of those four angles that are inside quadrilateral BCOM, they must be equal to, in total to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Okay? So here, the sum of three angles plus the size of the fourth, plus the size of the fourth angle, in total they must be equal to 360 degrees. Here we subtract 270 degrees from this equation, and we get that the missing angle, angle DMO, is equal to 360 degrees minus 270 degrees, it is equal to 90 degrees. So it is actually a right angle. Angle DMO is a right angle, it is equal to 90 degrees. So actually, inside quadrilateral BCOM, we have four right angles. And any quadrilateral that has four right angles must be this rectangle, if not a square. So we will relate to quadrilateral BCOM as a rectangle. Okay. Quadrilateral BCOM is a rectangle because of the fact that it has four right angles. And we also know that the opposite sides of a rectangle are equal to each other. That is to say, the opposite sides of rectangle BCOM, they must be equal to each other. That is to say, according to this rule, side BC must be equal to side OM. BC equals to OM according to the rule that the opposite sides of a rectangle are equal to each other. But according to what is given us in the question, side BC equals to 9. Side BC equals to 9. So from this equation, 9 equals to BC equals to OM, we will derive that side OM, it is also equals to 9 centimeters or units. Here side OM equals to 9 centimeters, okay? And here OF is the radius of the quarter circle, therefore it is absolutely a straight line. OM is the radius OF. This side OF is the radius of the quarter circle, therefore it is absolutely a straight line. Okay, I write it down. Side OF is the radius of the quarter circle, therefore it is a straight line. OF is a straight line. And we actually have the rule that states that the sum of the angles on one side of a straight line is equal to 180 degrees. So here CD is a straight line, so if we focus on the upper side of the straight line CD at point O, then here alpha plus beta equals to 180 degrees. Okay, so we can implement this rule number 3 in our drawing. In our drawing, we know that side OF is a straight line. So if we focus on the upper side of the straight line OF at point M, we know that the sum of the angles must be equal to 180 degrees. So if we focus on the upper side of the straight line OM, at point M, the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. At point F, on the upper side of the straight line OF at point M, the sum of the angles must be equal to 180 degrees. So which angles we have at the upper side of OF at point M? We have here 90 degrees plus angle OMF in total. The sum of those two angles must be equal to 180 degrees according to rule number 3, that the sum of the angles on one side of a straight line is equal to 180 degrees. So here we have 90 degrees plus angle DMF must be equal to 180 degrees. We subtract 90 degrees from this equation and we get that the missing angle DMF equals to 90 degrees. So if we know that this angle, it is a right angle, it is equal to 90 degrees. And CD is a straight line that is equal to 16 centimeters or 16 units, and we actually extended the straight line CD by a straight line. Therefore the result must be a straight line, because when you extend a straight line by a straight line, the result must be a straight line. Therefore CM is a straight line. CM is a straight line. So if we focus on this side of the straight line CM at point D, then the sum of the angles must be equal to 180 degrees. And this side of the straight line CM at point D. Okay, so at point D, so which angles we have at this side of the straight line CM at point D? We have here 90 degrees, and we have here this angle that is actually angle LDM. In total, the sum of those two angles must be equal to 180 degrees according to the rule that I mentioned, that the sum of the angles on one side of a straight line equals to 180 degrees. So here 90 degrees plus angle ADM must be equal to 180 degrees. Here we will subtract 90 degrees from this equation and we get that the missing angle LDM equals to 180 degrees minus 90 degrees. It is equals to 90 degrees. It is a right angle. So if we know that this angle, it is a right angle, it is equal to 90 degrees. Okay. In the next step, from point L, we will go perpendicular on the radius OF. I repeat again. Again, from point L, we will go perpendicular on the radius OF. Okay, yeah. So this angle equals to 90 degrees according to our construction. Okay. So actually, and we will define the touching point of the perpendicular from point L and MF as point N. Actually, by drawing this perpendicular on NF, we created here quadrilateral LDMN. We have here quadrilateral LDMN, and inside quadrilateral LDMN, we have 1, 2, 3 right angles. So repeat again. Inside quadrilateral LDMN, we have 1, 2, 3 right angles. And the sum of the right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle, that is actually angle DLM. In total, the sum of those four angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Again, this equation states that the sum of the angles in quadrilateral LDMN must be equal to 360 degrees. Here we subtract 270 degrees from this equation, and we get that the missing angle, angle DLM, angle DLM equals to 360 degrees minus 270 degrees, it is equal to 90 degrees, it is a right angle. So we found out that the missing angle DLM, it is a right angle, it is equal to 90 degrees. So actually, we found out that inside quadrilateral DLMN, we have 4 right angles. And any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we relate to quadrilateral DLMN as a rectangle. Okay, quadrilateral DLMN is a rectangle because of the fact that it has 4 right angles. Okay, quadrilateral DLMN is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. So the opposite sides of rectangle DLMN must be equal to each other. Here, the opposite sides of rectangle DLMN must be equal to each other. That is to say, side DL must be equal to side MN. DL must be equal to MN. Repeat again. Side DL must be equal to side MN, according to the rule that the opposite sides of a rectangle are equal to each other. Okay, but it is given as the question. That side DL equals to 12 units, 12 centimeters or units. So from this equation, 12 equals to DL equals to MN. We will derive that side MN is also equals to 12 units. Okay, side MN equals to 12 units, so we can write here that side MN equals to 12 units. You can see from the drawing that ON equals to 9 plus 12, that is 21 units. But the radius is a little bit bigger than 21 units. Why? Because the radius is OF. OF equals to R, that is the radius of the quarter circle. But ON, it is a little bit smaller or shorter than the radius that is OF. OF is the radius that is longer than ON, that is this line segment that is a little bit shorter than the radius OF. Therefore, the answer to the question is not 21. The radius of this quarter circle, it is not equals to 21 because it is a little bit longer than 21. You can see easily from the drawing that OF is longer than ON. ON equals to 21 and OF is longer than 21. That is to say, the radius is longer than 21 units. Therefore, the answer to the question is not 21 units. The radius of this quarter circle is not equal to 21 units, but it is a little bit longer, as you can see from the drawing. Okay, so here we found out that MN equals to 9 and 12 units, MO equals to 9 units, so we can write down that side line segment ON, it is equal to 9 plus 12, it is 21. So ON, line segment ON equals to 21 units. Actually, it is part of the radius. ON equals to 21 units, and it is part of the radius OF. ON equals to 21 units. So in the next step, we join points O and C together by a straight line. So by joining points O and C by a straight line, we created here right triangle OMC. Okay. So we will use the Pythagoras theorem in order to we'll implement the Pythagoras theorem on the green right triangle OMC. What is the definition? OC, it is for sure it is the hypotenuse of this right triangle for one side, but it is also the radius of the quarter circle that we are looking for. Why? Because point O is the center of the quarter circle. Point C is the point of the quarter circle itself. That is to say, this is exactly the definition of a radius. So OC is the radius of this quarter circle that is equal to capital R according to our definition. So the hypotenuse OC equals to capital R, that is the radius of this quarter circle. So we'll find out the value of the hypotenuse, and in this way we'll find out the radius of this quarter circle. Okay. So we'll focus on the green right triangle OMC. In the green right triangle OMC, by PT is a version for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. And the hypotenuse is OC, therefore the square of the hypotenuse is OC squared. That is, as I already said, OC is the radius of the quarter circle that we are looking for, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to OM squared plus CM squared. Okay, but actually here we don't have yet the length of side CM, so we'll define side DM as h. Side DM equals to h according to our definition, and as I already mentioned, quadrilateral DLMF is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. So in rectangle DLMF, we know that side DM equals to side LF. Side DM equals to side LF. But according to our definition, side DM equals to H. And from this equation, H equals to DM equals to LF, we derive that side LF is also equals to H. Side LF equals to H. Okay, here side LF equals to H. Okay, so now we know actually that side CM equals to 16 plus H, because CD equals to 16 and DM equals to H and CM equals to CD plus DM. That is to say, CM equals to 16 plus H. Okay, so I write down the Pythagoras theorem again. According to the Pythagoras theorem, we found out that integrate right triangle OMC, OC square equals to OM square plus CM square. Okay, so here OC equals to capital R, it is the radius of the quarter circle, therefore OC square will be equal to capital R square. That is the radius that we are looking for, and it is equal to OM square. OM equals to 9, therefore OM square is 9 square, that is 81, plus CM square. CM equals to CD plus DM, that is to say CM equals to CD, that is 16, plus DM, that is H. In total, CM equals to 16 plus H. So CM equals to 16 plus H, therefore CM square will be equal to 16 plus H square. So we found out that according to equation number 1, R square equals to 81 plus 16 plus H square. Okay, this is equation number 1. In equation number 1, we have two variables. R, that is the radius of the quarter circle that we are looking for, and we also have H that is missing. So, and we have only one equation, and it is impossible to solve one equation in two variables, so we create the second equation by joining points O and M together by straight line. Here point O is the center of the quarter circle. Point L is the point of the quarter circle itself. That is to say, this is exactly the definition of a radius. So OL is the radius of the quarter circle that is equal to capital R. Okay, OL equals to capital R. That is the radius of the quarter circle. And because of the fact that we did this construction from point L, we do perpendicular on OF, the radius, and this angle equals to 90 degrees. Therefore, triangle OLF is a right triangle because of the fact that it has one angle that is equal to 90 degrees. Therefore, triangle OLN is a right triangle. So we will implement the Pythagoras theorem on the orange triangle, orange right triangle, triangle OLF. So in the orange right triangle, triangle OLF, pi pt is abbreviation for Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay. The hypotenuse is OL, therefore the square of the hypotenuse is OL square, and it must be equal to the sum of the squares of the perpendiculars, that is to say it must be equal to ON square. You should see that ON is shorter, as I already mentioned a couple times before. ON is shorter than the radius that is OF. That is to say, OF will be a little bit longer than ON. That is to say, it will be a little bit longer than ON, that is equal to 9 plus 12, that is 21 units. So it is, according to the Pythagoras theorem, the square of the hypotenuse OL square equals to ON square plus LN square. I'll repeat again, in the orange right triangle OLF, according to the Pythagoras theorem, OL square equals to ON square plus LN square. As I've already mentioned before, OL is the radius of the quarter circle. It starts from the center of the quarter circle and ends at point L, that is the point of the quarter itself. Therefore, OL is the radius of the quarter circle, that is equal to capital R according to our definition. So OL square will be equal to R square, and it is equal to ON square. ON, as I already mentioned before, ON equals to OM plus MN. Okay? ON equals to OM plus MN. That is to say, it is equal to OM, that is 9, plus MN, that is 12. 9 plus 12 is 21. So ON equals to 21, and ON square is 21 square plus LN square. Here LN equals to age, according to what we have already found out. So LN square will be equal to age square. So now, actually, we created the second equation. So we have two variables with two different equations, and this is can be solved. We can solve two equations with two variables. Okay. So according to equation number 1, R square equals to 21 plus 16 plus 8 square, while according to equation number 2, R square equals to 21 square plus 8 square. In the next step, we'll create equation number 3 that states that R square according to equation number 1 must be equal to R square according to equation number 2. Okay, write it down. R square according to equation number 1 must be equal to R square according to equation number 2. So here equation number 3 says that R square equals to R square. So R square according to equation number 1 equals to 81 plus 16 plus h square. And it must be equal to R square according to equation number 2, that is equals to 21 square. 21 square is 441 plus 8 square. So here we have equation number 3 has only one variable that is missing, that is 8. So we can solve equation number 3 and we find out the value of h, and we will put the value of h inside the equation number 2, and in this way we'll find out the value of r, that is the radius that we are looking for. So here we'll open the brackets of this side of equation number 3, and we get that according to equation number 3, 81 plus 16 squared is 256 plus h squared plus 2 times 16 times h is plus 32h. That is equal to 441 plus h squared. Here we have h squared on both sides of the equation, so h squared will get cancelled. So on this side of the equation we have 441. On the other side of the equation we have 256 plus 81. So here 256 plus 81 equals to 337 plus 32h equals to 441. Here we'll subtract 337 from this equation and we'll get that according to equation number 3, 32h equals to 441 minus 337 equals to 104. Here we will divide this equation number 3 by 32 and we will get that h equals to 104 over 32. And 104 over 32 is equal to 3.25. Okay, h equals to 3.25. Now we'll substitute h in equation number 2 by 3.25 units. So here, according to equation number 2, r squared, the radius that you are looking for, equals to 441 plus h squared. But h equals to 3.25. So we substitute h by 3.25 and we get that r squared equals to 441 plus 3.25 squared. So 3.25 squared equals to 10.5625. So in total, r squared equals to 441 plus 10.5625. And actually here I found out that r squared equals to 441 plus 10.5625 equals to 451.5625. So in conclusion, I found out that r squared equals to 451.5625 units. So here we take a root out of this equation and we get that the radius that we are looking for equals to the square root of 451.5625 is 21.25 units. Okay. So, in conclusion, we found out that the radius of the quarter circle equals to 21.25 units. As I've already mentioned before, I told you that the radius of the circle, it is not equal to 9 plus 12, that is 21, but it is a little bit greater than 21. As you can see here, point N is very close to point F. So it is a little bit greater than 21. The radius of the quarter circle equals to 21.25 units. So you cannot answer to the question that is equal to 21, because it is a little bit greater than 21. So the radius of this quarter circle equals to 21.25 units. Okay, so we finished with the first question. In the next step, I present to you the second question, and we will answer to the second question in two different methods. So, in the drawing, we have triangle ABC. We know that angle ACB equals to 40 degrees, angle ADC equals to 80 degrees, side AC equals to Y units, side DC equals to X units, side AB of triangle ABC equals to X plus Y units, and the angle that we are looking for is angle ABC, that is equal to theta. So we want to find out the size of this angle, angle theta. We will answer on this question in two different methods. We will start with the first method. Okay, in the first method, we will do a construction. We will extend side BC by Y units. Okay, we will extend side BC in Y units. Here, side AC equals to Y units, so we will extend side BC by straight line in Y units. So, if this point is point E, it means that here we extended the straight line BC in such a way that line segment CE will be equal to Y units. So line segment CE equals to Y units according to our construction. Okay, repeat again. We extended the straight line BC in Y units. It means that line segment CE equals to Y units according to our construction. In the next step, we'll join points A and D together by a straight line. And we'll focus on the new triangle, triangle ACE, created here by joining points A and D together by a straight line. We created here triangle ACE. So we focus on triangle ACE. So I'll draw triangle ACE in a new page, and we'll focus on triangle ACE. Here C equals to Y units according to our construction. Side AC equals to Y units according to what is given us the question. So in triangle ACE, Let I copy it from the original drawing. This triangle, triangle ACE. Side AC equals to side CE. AC equals to CE. So both sides are equal to y, therefore they are equal to each other, of course. And we have the rule that in front of equal sides in the triangle there are equal angles. So in front those two equal sides there are equal angles. In front of this side we have this angle, in front of this side we have this angle. That is to say, those two angles are equal to each other according to the rule that I mentioned. So here angle CAE equals to this angle, that is actually angle AEC. Okay, angle CAE equals to angle AEC according to the rule that in front of equal sides in the triangle there are equal angles. Okay, so angle CAE equals to angle AEC. So if we define angle AEC as alpha, here angle AEC equals to alpha, then from this equation angle CAE equals to angle AEC equals to alpha, we derive that angle CAE is also equals to alpha. Angle CAE is also equals to alpha. Okay. Here, this angle, angle ACD or angle ACB equals to 40 degrees according to what is given as the question. Okay, so here, this angle is equal to 40 degrees according to what is given as the question. And we have the exterior angle theorem. According to the exterior angle theorem, an exterior angle of a triangle is equal to the sum of the two interior angles that are not adjacent to it. So I will read the exterior angle theorem again. According to the exterior angle theorem, an exterior angle of a triangle is equal to the sum of the two interior angles that are not adjacent to it. So here I'll explain what I mean here. Here if we have triangle ABC, this is triangle ABC, that could be any triangle. And angles alpha, beta, and gamma are defined as interior angles of triangle ABC. I write it down. Alpha, beta, and gamma are defined as interior angles of triangle ABC. Okay, and this angle that I will call to it angle E. Angle E is defined as exterior angles. Why? Because it is located outside the triangle, while the other angles, the three interior angles, are located inside the triangle. Therefore, they are defined as interior angles. So angle E is an exterior angle. And according to the exterior angle theorem, an exterior angle of a triangle, that is to say angle E is equal to the sum of the two interior angles that are not adjacent to it. So angle E equals to the sum of the two interior angles that are not adjacent to it. Here angle gamma is adjacent to angle E. And the two other interior angles that are not adjacent to it are alpha and beta. And the sum of those two angles are alpha plus beta. That is to say, the size of angle E, that is the exterior angle, is equal to alpha plus beta. So here, the exterior angle E equals to alpha plus beta because it is equal to the sum of the two interior angles that are not adjacent to it. Those two angles are defined as interior angles and they are not adjacent to it. Therefore, the sum of those two angles is alpha plus beta, and this is equal to the size of the exterior angle, angle E. Okay, so we can actually implement the exterior angle theorem in our drawing, because in our drawing we have those two angles that are defined as the interior angles of triangle ACE, and here this angle that is equal to 40 degrees, this angle that is equal to 40 degrees, it is defined as an exterior angle, and according to the exterior angle theorem, the value of this angle that is equal to 40 degrees, it is equal to the sum of the two interior angles that are not adjacent to it. And the sum of the two interior angles that are not adjacent to it is alpha plus alpha. Alpha plus alpha equals to 40 degrees. Okay, alpha plus alpha equals to 40 degrees according to the exterior angle theorem. So we found out that according to exterior angle theorem, alpha plus alpha equals to 40 degrees. Alpha plus alpha is 2 alpha. 2 alpha equals to 40 degrees. Here we'll divide this equation by 2 and we'll get that alpha equals to 20 degrees. So here this angle alpha equals to 20 degrees. Angle alpha equals to 20 degrees. So we can write down here that angle alpha equals to 20 degrees. Here angle AEC equals to alpha equals to 20 degrees, and angle EAC, it is also equals to alpha, that is equal to 20 degrees. Okay, we note that the sum of the angles in any triangle is equal to 180 degrees. So in triangle ADC, we have two angles that we note the value of them. This angle equals to 80 degrees, this angle equals to 40 degrees. So 40 degrees plus 80 degrees equals to 120 degrees. So if the sum of the angles of the two angles is 180 degrees, then the third angle must be equal to 60 degrees in order to complete the sum of the angles in this triangle ADC to 180 degrees. This angle must be equal to 60 degrees. Okay. So in the next step, we'll focus on triangle ADE. So I will copy triangle ADE in a new page, and we'll analyze triangle ADE. Okay, so I'll copy it in this page, and we'll analyze triangle ADE. Angle ADE equals to 80 degrees, and here this angle DAE equals to 60 degrees plus 20 degrees, it is 80 degrees. And here side DE equals to x plus y. Okay, side DE equals to x plus y. Here DE equals to x plus y. So in this triangle ADE, those two angles, they are both equal to 80 degrees. And we have the rule that in front of equal angles in the triangle, there are equal sides. So in front of this angle, we have side AE. In front of this angle, we have side DE. And according to the rule that I mentioned, side AE must be equal to side DE. Okay, according to the rule that in front of equal angles in the triangle there are equal sides. In front of this angle we have side AE, in front of this angle we have side DE, therefore side AE must be equal to side DE, according to the rule that I mentioned. But here we know that side DE equals to x plus y, so we can write here that side DE equals to x plus y. And from this equation x plus y equals to DE equals to AE, we will derive that side AE is also equals to x plus y. Side AE equals to x plus y. Okay, we found out that side AE equals to x plus y. So, in the next step, we will focus on the big triangle ABE. So I copied the big triangle ABE in a new page, and we'll analyze triangle ABE. This is triangle ABE that I copied from the original drawing. Angle ABE equals to theta. We have already found out that angle AEB equals to 20 degrees. It is giving us the question that side AB equals to x plus y in its length. And we just right now found out that side AE of triangle ABE is also equals to x plus y. Okay, so actually this is triangle ABE that I copied from the original drawing. And it is very easy to see from the drawing that both those two sides, side AB equals to x plus y, and side AE also equals to x plus y. That is to say, side AB equals to side AE. Okay? So both those two sides are equals to x plus y, therefore they are equal to each other. So side AB equals to side AE, that is to say, actually triangle ABE is an isosceles triangle. And according to the rule that I mentioned before, that in front of equal angles in the triangle, in front of equal sides in the triangle, there are equal angles. Repeat again. In front of equal sides in the triangle, there are equal angles. So here we know that side AE equals to side AB. So in front of side AE we have angle theta, and in front of side AB we have 20 degrees. So those two angles must be equal to each other. That is to say, angle theta must be equal to 20 degrees. Okay, so we found out that angle theta equals to 20 degrees. Okay, and that is the answer to the question. So we finished with the first method. In the next step, I will present to you the second method. So, in the second method, we'll focus on triangle ADC. In triangle ADC, this angle equals to 80 degrees, this angle equals to 40 degrees. 40 degrees plus 80 degrees is 120 degrees. So the missing angle must be equal to 60 degrees in order to complete the sum of the angles in triangle ADC to 180 degrees. The missing angle must be equal to 60 degrees. Very simple. So this angle must be equal to 60 degrees. We define side AD as A, and in the next step I will present to you a new law, that is the law of sines. I already mentioned the law of cosines. Now we will focus on the law of sines. The law of sines, like the law of cosines, it is true in any triangle. So what is the law of sines? So if we have triangle ABC, that could be any triangle. This is triangle ABC. Side BC of triangle ABC equals to A units in its length. Side AC of triangle ABC equals to B units in its length. And side AB of triangle ABC equals to C units in its length. Then the following equation is true, that A over sine A, capital A, is the size of this angle, angle BAC. Okay, it is equal to B over sine B. Likewise, capital B is the size of this angle, angle ABC, and it is equal to C over sine C. Okay, C over sine C again. Capital C is the size of this angle, angle ACB. So according to the law of cosines, A over sine A equals to B over sine B equals to C over sine C. And A, B, and C in the numerator are the lengths of the sides of triangle ABC. So we actually can implement the law of sines in our triangle ADC. This is triangle ADC, and we will implement the law of sines in this triangle ADC. So according to the law of sines, if we focus on triangle ADC, AD over sine 40 degrees AD over sine 40 degrees equals to DC over sine 60 degrees and it is equal to AC over sine 80 degrees. Okay, so actually this equation that I wrote here, it is the implementation of the law of sines in triangle ADC. AD over sinus 40 degrees equals to DC over sinus 60 degrees equals to AC over sinus 80 degrees. Here AD equals to X according to what is given as the equation, so we'll substitute AD by X and we get it X over sinus 40 degrees equals to, here AD equals to A according to our definition. Here AD equals to A according to our definition, so here AD equals to A over sinus 40 degrees and it is equals to DC over sinus 60 degrees. DC indeed equals to X, so we substitute DC by X. So it is X over sinus 60 degrees and it is equal to AC over sinus 80 degrees and AC equals to Y according to what is given as the equation, so we'll substitute AC by Y. It is Y over sinus 80 degrees. So in conclusion, we found out that according to equation number 1, A over sinus 40 degrees equals to X over sinus 60 degrees equals to Y over sinus 80 degrees. Okay, we will define each expression as K. So we'll define Y over sinus 80 degrees equals to X over sinus 60 degrees equals to A over sinus 40 degrees, and we'll define the three expressions as K. That is to say, they are all equal to K. Because of the fact that they are all equal to each other, we can define them all as they are all equal to K. Because they are equal to each other, we can say that they are all equal to K. Okay? So here from equation number 1, we can derive that A over sinus 40 degrees equals to K. So A over sinus 40 degrees equals to K. This expression equals to K according to our definition. Here we will multiply equation number 1 by sinus 40 degrees and we will get that A equals to K times sinus 40 degrees. Okay? According to equation number 1, A equals to K times sinus 40 degrees. Likewise, we derive from the long equation that X over sinus 60 degrees, it is also equals to K. Okay? X over sinus 60 degrees, it is equal to K. This will be equation number 2. Here we will multiply this equation by sinus 60 degrees and we'll get that according to equation number 2, x equals to k times sinus 60 degrees. Okay. So here we have equation number 1 that states that a equals to k times sinus 40 degrees, and according to equation number 2, x equals to k times sinus 60 degrees. In the next step, we derive the third equation from this long equation. Here, this expression y over sinus 80 degrees equals to k. Okay. According to equation number 3, y over sinus 80 degrees equals to k. Here we multiply this equation number 3 by sinus 80 degrees, and we will get that according to equation number 3, y equals to k times sinus 80 degrees. So actually we have 3 equations. We have the value of x in equation number 2, we have the value of a in equation number 1, and we have the value of y in equation number 3. Okay. So in the next step, we will focus on triangle ABD, and we will implement the law of sines in this triangle ABD. Okay, so in triangle ABD, according to the law of sines, in triangle ABD. But before that, we know that here ABC is a triangle, and because of the fact that ABC is a triangle, BC is one side of triangle ABC. So BC is a side of a triangle, it is absolutely a straight line. BC is a straight line, and if we focus on the upper side of the straight line BC at point D, we know that the sum of the angles on the upper side of the straight line BC at point D must be equal to 180 degrees. Okay, so here we can write down that angle ADB plus this angle ADC that is equal to 80 degrees. In total, the sum of the angles in the upper side of the straight line BC at point D, it must be equal to 180 degrees. Here we subtract 80 degrees from this equation, and we'll get that the missing angle ADB, equals to 100 degrees. This angle equals to 100 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. Okay, so now we will implement the law of sines in this triangle ADB. Okay, So here in triangle ADB, according to the law of sines, we will get that x plus y over sinus 100 degrees it must be equal to a over sinus theta. Okay, this equation is the implementation of the law of sines in triangle ADB. According to the law of sines, x plus y over sinus 100 degrees must be equal to a that is a over sinus theta. Okay. Now we'll substitute x by k sinus 60 degrees. We'll substitute a by k sinus 40 degrees. And we'll substitute y by k sinus 80 degrees. Okay? We'll do it now and we'll get that x equals to k sinus 60 degrees plus y that is equal to k times sinus 80 degrees over, so it is x plus y over sinus 100 degrees that is equal to a, and a equals to k sinus 40 degrees, so we substitute a by k times sinus 40 degrees over sinus theta. So in conclusion, we found out that according to equation number 2, k times sinus 60 degrees plus k times sinus 80 degrees equals over sinus 100 degrees equals to sinus k times sinus 40 degrees over sinus theta. So here we have k on both sides of the equation, so k will get cancelled. We can divide the equation by k, and so in this way k will get cancelled. In the next step, we will cross multiply this equation, equation number 2, and we get that according to equation number 2, sinus 60 degrees plus sinus 80 degrees times sinus theta equals to sinus 40 degrees times sinus 100 degrees. So here we will divide this equation, equation number 2, by sinus 80 degrees plus sinus 60 degrees, and we get that sinus theta equals to sinus 40 degrees times sinus 100 degrees over sinus 60 degrees plus sinus 80 degrees. Okay. So we have the trigonometric identity that states that sinus 90 degrees plus theta equals to cosine theta. We will use this trigonometric identity in order to find the value of sinus 100 degrees. According to this trigonometric identity, the value of sinus 100 degrees, first of all, 100 degrees is 90 plus 10. So it is sinus 90 degrees plus 10 degrees. And this expression, sinus 90 degrees plus 10, equals to cosine 10 degrees, according to this trigonometric identity that sinus 90 degrees plus theta equals to cosine theta. So we found out in conclusion that sinus 100 degrees equals to cosine 10 degrees. Okay? Therefore, we'll substitute sinus 100 degrees by cosine 10 degrees, but we will also find out, we'll use the second trigonometric identity that states that sinus 2a equals to 2 sinus a cosine a. Okay, sinus 2a equals to 2 sine a cosine a. We'll use this trigonometric identity in order to find out the value of sinus 40 degrees. So what is the value of sinus 40 degrees according to this trigonometric identity? The value of sinus 40 degrees, actually, first of all, sinus 40 degrees is sinus 2 times 20 degrees. And sinus 2 times 20 degrees, according to this trigonometric identity, will be equal to 2 times sinus 20 degrees times cosine 20 degrees. So in conclusion, we found out that sinus 40 degrees equals to 2 times sinus 20 degrees times cosine 20 degrees. That is to say, we can substitute sinus 40 degrees by 2 times sinus 20 degrees times cosine 20 degrees, and we will also substitute sinus 100 degrees by cosine 10 degrees. We'll do it now. We will get that according to equation number 2, and according to the trigonometric identity that I presented to you, we'll get that sinus theta equals to sinus 40 degrees, but sinus 40 degrees equals to 2 times sinus 20 degrees times cosine 20 degrees. So we substitute sinus 40 degrees by 2 times sinus 20 degrees times cosine 20 degrees times, according to equation number 2, we have also times sine 100 degrees, and we already found out that sine 100 degrees equals to cosine 10. So we substitute sine 100 degrees in equation number 2 by cosine 10 degrees, because they are equal to each other, according to the trigonometric identity that I presented to you. And we have to divide it by sine 60 degrees plus sine 80 degrees. Okay, so according to equation number 2, we found out that sinus theta equals to 2 sine 20 degrees times cosine 20 degrees times cosine 10 degrees over sinus 60 degrees plus sinus 80 degrees. Okay, and we have the third trigonometric identity that states, here we have in the denominator sinus 60 degrees plus sinus 80 degrees. For this expression, we have the following trigonometric identity that states that sinus B plus sinus C is equals to 2 times sinus d plus c over 2 times sinus times cosine d minus c over 2. Okay, repeat again. According to the trigonometric identity, sinus c plus d equals to 2 times sinus d plus c over 2 times cosine d minus c over 2. So now we will use this trigonometric identity in order to find out the value of sinus 60 degrees or sinus 80 degrees plus sinus 60 degrees. According to this trigonometric identity, we will get that it will be equal to 2 times sinus d plus c over 2. D is 80, c is 60, and 80 plus 60 is 140, and 140 over 2 is 70 degrees, times cosine d minus c over 2. D is 80 degrees, C is 60 degrees, 80 degrees minus 60 degrees is 20 degrees, and 20 degrees over 2 is 10 degrees. So cosine d minus c over 2 is 10 degrees. So in conclusion, we found out that sinus 60 degrees plus sinus 80 degrees equals to 2 times sinus 70 degrees times cosine 10 degrees. So we can substitute sine 60 degrees plus sine 80 degrees by 2 times sinus 70 degrees times cosine 10 degrees. We'll do it now and we'll get that sinus theta, according to equation number 2, it is equal to 2 times sinus 20 degrees times cosine 20 degrees times cosine 10 degrees, and we'll substitute sinus 60 degrees plus sinus 80 degrees by 2 times sinus 70 degrees times cosine 10 degrees. Okay, so here we have cosine 10 degrees in the numerator and cosine 10 degrees in the denominator, so cosine 10 degrees will get cancelled. We have 2 in the numerator and 2 in the denominator, so 2 will also get cancelled. And we left only, according to equation number 2, sinus theta equals to sinus 20 degrees times cosine 20 degrees over sinus 70 degrees. And here we have another trigonometric identity that states that sinus 90 degrees minus theta equals to cosine theta. Repeat again. The trigonometric identity states that sinus 90 degrees minus theta equals to cosine theta. So according to this trigonometric identity, sinus 70 degrees equals to sinus 90 degrees minus 20 degrees, and according to this trigonometric identity that sinus 90 degrees minus theta equals to cosine theta, we will get that sinus 90 degrees minus 20 degrees equals to cosine 20 degrees. So in conclusion, we found out that sinus 70 degrees equals to cosine 20 degrees, repeat again, we found out that sinus 70 degrees equals to cosine 20 degrees. Therefore, we can substitute sinus 20 degrees in the denominator of equation number 2 by cosine 20 degrees. We'll do it now and we'll get that according to equation number 2, sinus theta equals to sinus 20 degrees times cosine 20 degrees over sinus 70 degrees, and we just right now found out that sinus 70 degrees equals to cosine 20 degrees. Therefore, we will substitute sinus 70 degrees by cosine 20 degrees. Okay, so according to equation number 2, we found out that sinus theta equals to sinus 20 degrees over cosine, sinus 20 degrees times cosine 20 degrees over cosine 20 degrees. So we have cosine 20 degrees in the numerator, cosine 20 degrees in the denominator, so cosine 20 degrees will get cancelled, and we're left only with sinus theta. According to equation number 2, sinus theta equals to sinus 20 degrees. So if sinus theta equals to sinus 20 degrees, it means that theta equals to 20 degrees. Okay, theta equals to 20 degrees. According to the rule that if sinus alpha equals to sinus beta, then alpha equals to beta. Okay, sinus theta equals to sinus 20 degrees, it means that theta equals to 20 degrees. So according to the second method, we found out that the size of angle theta is equal to 20 degrees. In the next step, so we finished with the second method. In the next step, I will summarize the lecture. We'll start with the first question, of course. So in the drawing we have a quarter circle, and we know that side BC equals to 9 units, side CD equals to 16 units, and side DL equals to 12 units. Angle OBC, this angle equals to 90 degrees. Angle BCM, this angle also equals to 90 degrees. And this angle CD, this angle also equals to 90 degrees. Angle CDL equals to 90 degrees. And our mission here is to find out the radius of this quarter circle. So because of the fact that this is a quarter circle, it means that point O is the center of the quarter circle. And also this angle BOF, this angle equals to 90 degrees. And the first thing that we can conclude from the fact that this is a quarter circle is that side AO equals to side OF, and they are both the radii of this quarter circle. So we define the radius of the quarter circle as capital R, therefore AO equals to capital R. That is the radius of the quarter circle. Likewise, OF it is also equals to the capital R, that is also the radius of this quarter circle. Okay. So first of all, we did the construction here. We extended the straight line CD by a straight line until it touches the circle, and until it touches side OF at point M. Point M is the touching point of the extended straight line CD and OF. So here, by doing this construction, we created quadrilateral BCDOM, BCOM, this quadrilateral, and inside this quadrilateral we have 1, 2, 3 right angles. Okay, and the sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle, that is actually this angle, DMO. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Okay, so here we subtracted 270 degrees from this equation and we found out that the missing angle DMO equals to 360 degrees minus 270 degrees, it is equal to 90 degrees. It is a right angle. So we actually found out that inside quadrilateral BCOM we have 4 right angles. And any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we relate to quadrilateral BCOM as a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. So the opposite sides of rectangle BCOM are equal to each other. That is to say, side BC must be equal to side OM. BC equals to OM, but it is given us the question that side BC equals to 9 units. So we can write it that BC equals to 9 units. And from this equation, 9 equals to BC equals to OM. We will derive that side OM is also equals to 9 units. Here, side OM equals to 9 units. Okay, then we know that OF, line segment OF is the radius of the quarter circle. OF as a radius of the quarter circle, it is absolutely a straight line. Okay, OF is the radius of the quarter circle, must be a straight line. And we have the rule that the sum of the angles on one side of the straight line is equal to 180 degrees. Okay, so here if we focus on the upper side of the straight line OF at point M, then the sum of the angles here must be equal to 180 degrees. So which angles we have here? We have this angle that is equal to 90 degrees, plus this angle that is actually angle DMF. In total, the sum of those 2 angles must be equal to 180 degrees. Here, 90 degrees plus angle DMF must be equal to 180 degrees. We subtracted 90 degrees from this equation, and we found out that the missing angle DMF equals to 90 degrees. So this angle equals to 90 degrees. Okay, and likewise CD is a straight line. It is given us the question that CD is a straight line, and when we extended the straight line CD by straight line, the result must be a straight line. So the result of the extension of the straight line CD by straight line is CM. When you extend the straight line by straight line, the result must be a straight line. So CM, that is the result of the extension of the straight line CD by straight line, must be also a straight line. So CM is a straight line, and we know that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on this side of the straight line CM at point D, then the sum of the angles must be equal to 180 degrees. So which angles we have on this side of CM at point D? We have here 90 degrees, plus this angle, that is actually angle LOM. In total, the sum of those 2 angles must be equal to 180 degrees according to the rule that I mentioned. Here we subtracted 90 degrees from this equation and we found out that the missing angle, this angle, equals to 90 degrees. Okay, so then now we found out that those 2 angles are both equal to 90 degrees. In the next step, from point L, this point, we draw perpendicular on the radius OF. Again, I repeat again, from point L, we draw perpendicular on the radius OF. That is to say, this angle equals to 90 degrees according to our construction. So actually, we created here quadrilateral LDMN. In quadrilateral LDMN, we have 1, 2, 3 right angles. Okay, inside quadrilateral LDMN, we have 3 right angles. And we know that the sum of 3 right angles is 270 degrees plus the size of the fourth angle. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Okay, here the sum of the angles in quadrilateral LDMN is equal to 360 degrees. This equation expresses the fact that the sum of the angles inside quadrilateral LDLM and LDMN is equal to 360 degrees. Okay, so here we subtracted 270 degrees from this equation and found out that the missing angle DLM, is a right angle. It is equal to 90 degrees. So here, this is the missing angle, and this angle equals to 90 degrees. So actually we found out that inside quadrilateral LDMN we have 4 right angles. And any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we relate to quadrilateral LDMN as a rectangle. Here, quadrilateral LDMN is a rectangle. Okay, why? Because it has 4 right angles. And you know that the opposite sides of a rectangle are equal to each other. So in rectangle DLMF, its opposite sides are equal to each other. That is to say, DL equals to LM. DL equals to MN. According to the rule that the opposite sides of a rectangle are equal to each other, we get that DL equals to MN. In rectangle DLMN, DL must be equal to MN. But according to what is given us in the equation, DL equals to 12 units. And from this equation, 12 equals to DL equals to MN, we will derive that MN is also equals to 12 units. Okay? So here actually, ON equals to 9 plus 12, that is 21 units. Then we joined points O and C together by a straight line, and we implemented the Pythagoras theorem on the green and orange triangle COM. This angle equals to 90 degrees, therefore triangle COM is a right triangle, and we implemented the Pythagoras theorem on this green and right triangle COM. In the right triangle COM, according to the Pythagoras theorem, CO square equals to OM square plus CM square. Okay, repeat again. In the right triangle COM, or C square equals to OM square plus CM square. And here, we actually know that quadrilateral DLMN, the orange quadrilateral, is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. So we defined side DM, this side as H. And because of the fact that the opposite sides of this rectangle are equal to each other, it means that side DM must be equal to side LF. Here, DM equals to LF. But according to our definition, DM equals to H. DM equals to H. So from this equation, H equals to DM equals to LF, we will derive that LF is also equals to H. Here, LF is also equals to H. Okay? So here we implemented the Pythagoras theorem on this right triangle, triangle COM. Now we know that the length of side CM equals to the CD plus DM. CD plus DM is CD is 16 and DM is 8. So in total the length of side DM is 16 plus H. Okay, so in the right triangle CMO, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, OC square equals to OM square plus CM square. OM is the radius of the quarter circle, here OC is the radius of the quarter circle. Why? Because point O is the center of the quarter circle and point C is the point of the quarter circle itself. This is exactly the definition of a radius. So OC is the radius of this quarter circle that is equal to capital R according to our definition. So OC equals to capital R, therefore OC squared will be equal to capital R squared. And it is equal to OM squared. OM equals to 9, so OM squared is 9 squared, that is 81. So R squared equals to 81 plus CM squared. CM equals to 16 plus H, therefore CM squared is 16 plus H squared. So in conclusion, we found out that according to equation number 1, R squared equals to 81 plus 16 plus H squared. Okay. So here, in the next step, we join points O and L together by a straight line. Point O is the center of the quarter circle. Point L is the point of the quarter circle itself. So, therefore, OL is the radius of this quarter circle that is equal to capital R according to our definition. So, OL is the radius of the quarter circle that is equal to capital R. Then we implemented the Pythagoras theorem on the orange triangle, on the orange right triangle, triangle LOF. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the square of the perpendiculars, that is to say, LO square equals to ON square plus LN square. LO square equals to ON square plus LN square. LO equals to capital R. Therefore, NO square is capital R square, and it is equal to NO square. NO equals to 9 plus 12, that is 21. Therefore, NO square is 21 square plus LN square. LN equals to H, therefore LN square equals to H square. So in conclusion, according to equation number 2, we found out that R square equals to 21 square plus H square. So we have two different expressions for the radius for R square, that is the radius of the quarter circle. Therefore, we create equation number 3 that states that R square according to equation number 1 must be equal to R square according to equation number 2. So R square according to equation number 1 is 81 plus 16 plus 8 square, and it must be equal to R square according to equation number 2, that is 441 plus 8 square. Then we open the brackets on this side of equation number 3 and we found out that 81 plus 16 plus 8 square equals to 16 square, that is 256 plus 8 square plus 2 times 16 times 8 is 32H. And it must be equal to 441 plus 8 square. Here we have 81 plus 256 is 337. And plus 32H must be equal to 441. We subtracted 337 from this equation number 3 and found out that according to equation number 3, 32H equals to 441 minus 337 is 104. So in conclusion, according to equation number 3, we found out that 32H equals to 104. Here we divided this equation number 3 by 32 and found out that according to equation number 3, H equals to 104 over 32. 104 over 32 is 3.25 units. So we found out that H equals to 3.25 units. After we found out the value of H, we put the value of H inside equation number 2, according to equation number 2, R square equals to 441 plus H square. So we substituted H square, we substituted H by 3.25. If H equals to 3.25, it means that H square will be equal to 3.25 square. So in conclusion, we found out that R square equals to 441 plus H square, that is 3.25 square. 3.25 square is 10.5610.5. So in conclusion, found out that R square equals to 441 plus 10.5625. That is to say, here x R square equals to 451.5625. We took a root out of this equation and found out that the radius of this quarter circle, it is equal to the square root of 451.5625, that is 21.25 units. And conclusion found out that the radius of this quarter circle equals to 21.25 units. As I've already mentioned here, the radius of this quarter circle, it is a little bit greater than 21. And the answer to this question is not that the radius is not equal to 9 plus 12, because the radius it is a little bit greater than 9 segment ON. So it is 21.25 units. It is a little bit greater than 21 units. So we finished with the first question. Then I presented to you the second question, and we solved the second question in two different methods. So here in the drawing we have triangle ABC, side AB equals to x plus y, angle DAC equals to angle ADC equals to 80 degrees, angle ACD equals to 40 degrees, side DC equals to x, this angle actually equals to angle ADC equals to 80 degrees, and side CE equals to y, side DC equals to x, side AB equals to x plus y, and our mission is to find out the value of angle ABC that is equal to theta. Okay, so in the first method we did the construction. We extended side BC by a straight line in such a way that CE will be equal to y. Then we joined points A and D together by a straight line, and this way we created triangle ACE. So in triangle ACE, it is an isosceles triangle. Why? Because of the fact that those two sides are both equal to y, therefore they are equal to each other. And we know that in front of equal sides in the triangle there are equal legs. That is to say, those two angles must be equal to each other because of the fact that they are located in front of equal sides. In front, those two sides they are both equal to y. So here AC equals to CE equals to y. Therefore, those two angles are equal to each other. So angle CAE equals to angle AEC. So if one angle equals to alpha, if angle AEC equals to alpha, then it means that the other angle, angle CEA, must be also equal to alpha. Okay, then I presented to you the angle bisector theorem. According to the angle bisector theorem, presented to you the external angle theorem. According to the external angle theorem, an external angle of a triangle is equal to the sum of the two interior angles that are not adjacent to it. So here in triangle ABC, angles alpha, beta and gamma are defined as the interior angles because of the fact that they are located inside the triangle, and this angle, angle E, that is outside the triangle, is defined as an external angle, and the value of these external angles equals to the sum of the two interior angles that are not adjacent to it. Here angle alpha and angle beta are not adjacent to it, therefore angle E equals to alpha plus beta. Then we implemented the angle bisector theorem in our triangle ACE. We have those two angles, alpha and alpha, they are both interior angles, and this angle that is equal to 40 degrees, it is an exterior angle. So according to according to the exterior angle theorem, we get that the value of the exterior angle that is equal to 40 degrees, it is equal to the sum of the two angles that are not adjacent to it. That is to say, it's equal to alpha plus alpha. So 40 degrees equals to alpha plus alpha. So here alpha plus alpha equals to 40 degrees, that is to say 2 alpha equals to 40 degrees. We divided this equation by 2 and we found out that angle alpha equals to 20 degrees. Here those two angles, they are both equal to alpha, therefore they are equal to 20 degrees. Then we focus on the right triangle, triangle ADE. In the right triangle, triangle ADE, this angle EAD equals to 60 degrees plus 20 degrees, that is 80 degrees. So in the right triangle ADE, we have two angles that are equal to each other, and we have the rule that in front of equal angles in the triangle there are equal sides. That is to say, in front of those two equal angles there are equal sides. In front of this angle we have side DE, in front of this angle we have side AE, therefore side AE must be equal to side DE because of the fact that they are located in front of equal angles. So side AE equals to side DE, but according to what is given as the question, side DE equals to x plus y. According to what we have already found out, side DE equals to x plus y. So from this equation, x plus y equals to DE equals to AE, we derive that side AE is also equals to x plus y. Side AE equals to x plus y. Then we focus on the big triangle, triangle ABE. According to what is given as the question, side AB equals to x plus y. This angle equals to theta, that is the angle that we are looking for. We have already found out that this angle AEB equals to 20 degrees. And we just right now found out that side AE equals to x plus y. So actually, triangle ABE is an isosceles triangle. Why? Because side AB equals to side AE. Both sides are equal to x plus y, therefore they are equal to each other. So in an isosceles triangle, we know that those two angles must be equal to each other. So according to the rule that in front of equal sides in the triangle there are equal angles, we get that in front of this side we have angle theta. In front of this side we have angle that is equal to 20 degrees, therefore those two angles must be equal to each other. That is to say, angle theta must be equal to 20 degrees. Okay, so we finish with the first method, then I present to you the second method. In the second method, we have in this triangle, this angle equals to 80 degrees, this angle equals to 40 degrees. 80 degrees plus 40 degrees is 120 degrees, therefore this angle must be equal to 60 degrees. In order to complete the sum of the angles in triangle ADC to 180 degrees, this angle must be equal to 60 degrees. Okay, and we define side AD as A. And then I presented to you the law of sines, and we implemented the law of sines in the two triangles, in triangle ABD and also in triangle ADC. So what is the law of sines? The law of sines is true in any triangle. If we have this triangle, triangle ABC, that could be any triangle. Side AB equals to C units, side BC equals to A units, and side AC equals to B units. Then A over sine A equals to B over sine B equals to C over sine C. Here capital A is the size of this angle, capital B is the size of this angle, and capital C is the size of this angle. And A and the small a, B, and C are the length of each side of the triangle. Okay, so according to the law of cosines, A over sine A equals to B over sine B equals to C over sine C. Then we implemented the law of sines in this triangle, triangle ADC. And according to the law of sines, we get that in this triangle, triangle ADC, according to the law of sines, we will get that AD over sinus 30 degrees equals to DC over sinus 60 degrees equals to AC over sinus 80 degrees. Okay, so AD equals to A, so we substitute AD by A. DC equals to X, we substitute DC by X, and AC equals to Y, we substitute AC by Y. And we got this equation. Then we defined this expression that is equal to K. We created three different equations from this long equation, and from the three different equations we found the values of A, X and Y. So those are the values of X, A and Y. Then we implemented the law of sines in this triangle ABD. According to the law of sines in this triangle ABD, here this angle equals to 80 degrees, so this angle must be equal to 100 degrees in order to complete the sum of the angles on the upper side of the straight line BC to 180 degrees. This angle must be equal to 100 degrees. So here in triangle ABD, according to the law of sines, we get that xy over sin 60 degrees equals to A over sine theta. Okay, then we substituted A, X and Y by the values that we found here, and we got the equation here, and then we used a couple of trigonometric identities in order to solve the equation, and finally we found out that theta equals to 20 degrees, exactly according to what we have already found out in the first method. Okay, so in both methods we found out that the size of this angle theta in triangle ABC is equal to 20 degrees. Okay, thank you very much.